We will present our project that we join an investment company and supervisors to pick 15 stock lists in the Stock Exchange of Thailand. After we pick our stock, we can ask two from three portfolio. First, we show minimum variance portfolio for low-risk investor. Second, we show minimum variance portfolio with 10% target expect returns per year. From medium risk investor, third, we show maximum expect return to standard deviation ratio portfolio for value investor.
The 15 stock we chose include TSM, TM, TLKM, MSFT, KLBF, JNJ, BOD, BRPT, EMTK, AMTM, GLN, BHP, UNTR, AGL, and lastly MDKA. After we chose the stock, we then later on gained statistic data on the monthly return for each stock for the past year. After we gained the data, we stored the data into the RedMat R Studio and merge it all together to make it easier for us to calculate other variables in the upcoming section. Next.
So first, we download the application to calculate the port. Then we create a port and use the information from the calculation in this. There are two constraints. First, full investment. Investing our money in mathematical terms, we have 15 stocks, and the sum of all the investment ratio is equal to 1. Another one is long only, which is long-term strategy. It is to sell and buy stock without borrowing money. And objective is the risk equal to standard deviation. The program will automatically minimize the risk. Finally, we download the application to calculate the port. It works by calculating our condition and insert the output in OPT2. And the print show the result. Here's our stock, and the number under stock is investing ratio. All the number have to combine equal to 1. And the objective measure is standard deviation, which equal to 0.05. Is equal to 5% risk. Next, please.
And next, similar to the previous one, for the second one, we will find the minimum variance portfolio with 10% targeted expected return per year. So we start with run the portfolio analytics and then put all the data into the port mini variance tool, which is the variable that we create for it. And then we keep add the constant full investment and long only. And then we keep adding constant 10% targeted expected return per year by type the program to focus on the return. And since the program will know automatically whether return should be maximized or minimized, because all people want the high return but low risk, so return will be maximized automatically. And we set the target at the 10% return, but since we want per year, so we have to divide it with 12. For the objective, we will set the objective of the port underscore mini underscore where to focus on the risk, which we already indicate as a standard deviation. And since standard deviation is the square root of the variance, so minimum number of the standard deviation also be the minimum number of the variance, which is the minimum risk that we can lower. Then we run the DE optim program to calculate the results and put all the optimized portfolio results into the port 2 variable and print it. Similar to before, we have weight of each portfolio that we will invest in each stock, and we get the risk as the standard deviation. For the last one, we have to maximum the expected return and minimize the standard deviation. So we run the portfolio analytics and create the variable port underscore max r underscore min sd with the, and put all of the data into it. Then we add the two constant full investment, which means that we will use all of our money to invest and to sum it up to be one. For the long only, it tell the program that we will use the long-term strategy to buy and sell stock stand forward. For the objective, we have two objectives here. The first one is to maximize the expected return by type return to be focused and then indicate as a mean. Program will know that you want to maximize return automatically, as well as for the risk that program will know to minimize it and minimize the standard deviation that which we indicate as a risk as well. Now here we calculate the optimization problem with the DE optim and put the result in the port 3 and print it. And here we get all of the results, which each weight will tell the proportion of investment in each stock of our portfolio, and mean refer to the return of our portfolio, which is about 2%, and standard deviation tell us that if you invest in this amount of investment or proportion, you will have a 5% risk in this portfolio. Thank you.
Thank you.
So next we will look for the value at risk and tail value at risk. First, we have to get these two value by we will using Studio to get this two value. First is mean and standard deviation. Mean we will get 7.74% and standard deviation is 5.77%. So we will use these three values to calculate value at risk by using this formula, and we will get this value. Also tail value at risk, we use this formula to get this value. So to summarize this model, we can say that we this portfolio have 5% chance that we will lose money at 6.75%, and in the worst case we can lose 9.16% at 5% chance. So we will look at CAPM data.
As we look into risk of investing in those stocks from our planned portfolio, we discriminate the risk into two, systematic and unsystematic. However, we only need to look forward to the systematic risk since we can only calculate that. And by that, we also look into CAPM, consisted of RI, IF, beta, and RM, where RI is the expected return on asset obtained by using weight and our chosen stock monthly return. IF is risk-free rate, RM is the expected return on market, and beta is our risk indicator. We use our weight calculated on our Studio program to calculate R1 and the formula RF minus R1. Replace that, and we regress using the regression tool using the market RF and R1. Then we get our beta. right here at the highlighted one on the coefficient. This beta is negative, mean that it is very low in risk. This is not usual. This is very unusual, but this means that our portfolio have a very low risk.